In this module, we will be studying about the multiplication rule of probability. We know that if E and F are two events in the same sample space S, then the conditional probability of event E, given that event F has occurred, is given by the probability of E given F is equal to the probability of E intersection F divided by the probability of F, where the probability of F is not equal to 0. This implies that the probability of E intersection F is equal to the probability of E given F multiplied by the probability of F. Similarly, the conditional probability of F, given that event E has occurred, is equal to the probability of F intersection E divided by the probability of E, such that the probability of E is not equal to 0. Now F intersection E is equal to E intersection F. This implies the probability of E intersection F is equal to the probability of F given E into the probability of E. From 1 and 2, we get the probability of E intersection F is equal to the probability of E given F into the probability of F. This is further equal to the probability of F given E into the probability of E. This is called the multiplication rule of probability. Now let's look at an example. Consider a pack of cards. 2 cards are drawn one after the other without replacing the first card back into the pack. Suppose the first card drawn from the pack is a queen and the second card drawn is a king. Then what would be the probability of the event? Let Q and K be the events of drawing a queen and a king card respectively. As we need to find the probability of drawing 2 cards one after the other without replacement, we have to find the probability of Q intersection K. Now, there are 4 queen cards in a pack of 52 cards. So, the probability of drawing a queen card is 4 divided by 52. The card drawn is not replaced. This implies that the number of cards available for the second draw is 51. Thus, the probability of drawing a king card, given that the first draw is a queen card, is 4 divided by 51, because there are 4 king cards present in 51 cards. From the multiplication rule of probability, we have the probability of Q intersection K is equal to the probability of K given Q into the probability of Q. Substituting the values of the probability of K given Q and the probability of Q in the rule, we get 4 divided by 663. Therefore, the probability of Q intersection K is equal to 4 divided by 663. Hence, the probability of first drawing a queen card and then a king card is 4 divided by 663. This multiplication rule can be extended to more than 2 events. For example, for 3 events E, F and G in sample space S, the multiplication rule is defined as the probability of E intersection F intersection G is equal to the probability of E into the probability of F given E into the probability of G given E intersection F is equal to the probability of E into the probability of F given E into the probability of G given EF. Let's consider an example. A box contains 12 black balls and 8 green balls. Suppose we take 2 black balls and then a green ball one after another without replacement. What would be the probability of the event of taking 2 black balls and a green ball? Let R be the event of taking a black ball from the box. Let B be the event of taking a green ball from the box. The total number of balls available in the box is 12 black balls plus 8 green balls, which is equal to 20 balls. First, a black ball is drawn, and since there are 12 black balls, the probability of taking a black ball is 12 divided by 20, which is equal to 3 divided by 5. Since the ball drawn is not replaced in the box, 11 black balls are now available, and the total number of balls is 19. Now the probability of taking another black ball is given by the probability of R given R is equal to 11 divided by 19. Since another black ball is drawn, the total number of available balls in the box is 19 minus 1, which is equal to 18. Therefore, the probability of taking a green ball with the condition that 2 black balls have already been taken is given by the probability of B given RR. This is equal to 8 divided by 18 or 4 divided by 9. From the multiplication rule for 3 events, we have the probability of RRB is equal to the probability of R into the probability of R given R into the probability of B given RR. Substituting the values of the probability of R given R, and the probability of B given RR, we get the expression as shown. On simplifying, we get 44 divided by 285. Therefore, the probability of RRB is equal to 44 divided by 285. Hence, the probability of taking 2 successive black balls and a green ball is equal to 44 divided by 285.